Alright guys, we're going to start Unit 12 today, and Unit 12 is lines that intersect circles. Our objectives are to identify tangent, secant, and chords. Use properties of tangents to solve problems. Alright, so let's talk about this circle here. The interior of a circle is the set of all points inside the circle. The exterior of a circle is the set of all points outside the circle. Okay, so interior points would be inside the circle, exterior would be outside. A chord is a segment whose endpoints lie on the circle and the chord does not go through the center of that circle, okay? A secant is a line that intersects a circle at 2 points. Okay, so guys, a secant is just like a chord. The only difference is a chord has endpoints. A secant does not. Therefore, a chord is a segment, and a secant is a line that intersects that circle. And then a tangent is a line in the same plane as the circle that intersects the circle in exactly 1 point. Tangent is a line. It intersects the circle in exactly 1 point, and that point of intersection is called the point of tangency. Okay, so we're going to identify. And we want to identify our chords, okay? So, let's see. Well, let's just do this. Right here we have line M. Line M is tangent to that circle. So, this is going to be M. Let's call that line M. Okay? And then we have, let's see, line JL. Intersects not through the center, but intersects the circle. So that is called a secant. That's JM, and that is a line. Make sure you get your symbols right. Okay, and then we have KM is a chord, and actually the diameter is KM, and the radius of the radii is KL, LM, or LJ. So let's go back to the chord. JM and KLA. JM could have endpoints instead of a line, so there's a chord. All right. Pairs of circles. Two circles are congruent circles if and only if you have congruent radius. Concentric circles are coplanar circles with the same center. So you have the red circle and the blue circle, and they share the same center. And tangent circles, two coplanar circles that intersect at exactly 1 point, and they're called tangent, okay? These are internally tangent circles because you have one inside the other, and they intersect right here at this point. And then these are two externally tangent circles because they're on the outside of each other and they intersect right there at that 1 point. Alright, find the length of each radius, identify the point of tangency, and write the equation of the tangent line at this point. Okay, so for circle R, we need to find the radius. Here's the center. So there's the radius, and it is 2 units. Circle S, here's the radius to the outside of that circle, so that's 1.5 units. And then we have point of tangency. Well, point of tangency is where the two circles intersect. They intersect right there, so you go left 2 and then don't move any. So point of tangent C is left 2, 0. Okay, so the tangent line is this right here. All right, so your equation, let's call that equation of tangent line. So guys, anytime you have a horizontal line, your slope is 0, so it's y equals 0. All right, I'm going to do it again. I'm going to be quiet so you can figure this on your own. Okay, let's move on. All right, a common tangent is a line that is tangent to two circles. Line L and line M are common external tangents to circle A and B. Then we have lines P and lines Q are common internal tangents to circle A and B. So if you see the difference here, these are on the outside of the two circles. These are between the two circles, okay? All right, so let's talk about some theorems here. If a line is tangent to a circle, tangent to this circle, it is perpendicular to the radius drawn at the point of tangency. So line L, which is your tangent line, is perpendicular to your radius AB. If a line is perpendicular to a radius of a circle at a point on the circle, then the line is tangent to the circle. So this is saying M is perpendicular to CD at point D. So M is tangent to circle C because it's perpendicular. All right, so let's apply this. Checking my time here. Go ahead and read it quietly. Okay, so what we have here is this segment is and what we're trying to find is this right here. Well, I've got a right triangle, and my hypotenuse is 4,000 plus 120. Okay, so what I can do is I can take my hypotenuse, which is this EC. So EC is 4,120 squared minus this leg here, HC. And it will give me what I'm looking for. Okay, so this is going to simplify to 974,400. We need to round to the nearest mile, 987 miles. All right, another theorem. If two segments are tangent to a circle from the same exterior point, then the segments are congruent. Okay, so we have exterior point A. AB is tangent to the circle. It intersects right there. AC is tangent to the circle. It intersects right here. Therefore, segment AB is congruent to segment AC. All right, so we need to find HG, okay? And it's saying that GH and KH are tangent to the circle, therefore I know they are congruent from that theorem. So I know that HG is congruent to KH. So if I substitute in for my HG and my HK, I can solve for A. Okay, but we're trying to find HG. Well, HG is 4 plus 2A. We substitute 12 in for A. There's my answer. Okay, then move on. See if I can fit this last problem in. And I think I will get to, I'm going to be quiet and let y'all work this one on your own. All right, guys, that's it. Have a good one.